And this is typical tensile curve, which can be provided to Midas NFX. So this curve is used to describe nonlinear behavior, and sometimes it's named as monotonic curve. And I know this curve is already known for you because it's a very basic, let's say, knowledge from the college. So there is no point to talk too much about that. So if we take a look on this curve, for example, we can categorize a few regions like linear region, perfect plasticity, strain hardening, and necking. Actually, we have some questions in that case. When to use, for example, elastoplastic model. So this is very general question. So in any case, for example, when you want to model plasticity, when your material will experience plastic behavior. So the typical example is like, for example, sheet metal pressing. So we can use this model because you have to generate the permanent strain in these cases. So this is common example. Actually, our example, which I provide to you, will use this elastoplastic model. One of you is asking what is plastic hardening. The hardening is the feature of the material. So at this moment, I would like to refer to you to go to the strength of the material of the or some other book of the mechanics of maybe some materials tests, and you can find a lot of knowledge for that. So this is the hardening. Basically, the how to calculate hardening coefficients. In Midas NFX, we are specifying this as the function. So this data can be provided via experiments, and there are also some literature how to provide the coefficients. You can use even Excel to that, and some approximations. So I would like to say that if you have experimental data, you can always provide the curve. If one of you is asking if the metal bending springs back is occurring, how to model that? This is the feature of the material. So spring back will come, let's say, when your load, let's say, will be removed, and there will be some type of energy stored in the model. So this effect is provided automatically because not every, let's say, in terms of the sheet metal simulation, not every, let's say, single element will be experience the plasticity. So there will be some part which still remain elastic, and this will give you this effect. Okay, let's go back to the presentation.